Hello, can anyone hear me?
Yes, we can hear you.
Yes, hi. This is Anupama, and today I'm going to talk about software design patterns, and more specifically, I'm going to talk about factory pattern. Okay, well, this is a 2 hours long session, and if we are left with any of the time in the end, I will take up a couple of DS algo questions. Okay. And I'll be very, very happy to answer any of your questions if you have any, guys. And feel free to interrupt me anytime and ask your questions or clarifications on that. So with that, I think we have a few folks already joined. Would you like to have an intro session before I start my this factory pattern presentation, or how shall we take it ahead? Anybody wants to introduce themselves? Yes.
Quickly, because I'm working as a data scientist. I recently moved from C++ to Python, so that's why I want to learn Python in a better way.
Okay, okay, that's cool. Thank you, Vikas, for the introduction. Okay, so let's go ahead and let's get started with the presentation. Okay, so this is a factory pattern, and then we're going to do a small coding session at the end. Well, I'll be showing like how we can implement this with a small example and everything. Okay, so let's see. So today we are going to look at the following things. What exactly is a design pattern? Problems with a complex conditional code, problems that we face without a factory method, introducing a factory method, definition, motivation, and a class diagram for a factory method, and then a basic implementation of it, and then recognizing opportunities, how you can convert a normal code using this factory method, and then a bit of advantages and disadvantages of the factory method, and then applications, and at the end with the conclusions. So while implementing, first I'll show you a sample example of the code which doesn't include any factory method, and post that I will be showing how exactly we can use this method and make our code better. Okay, so having said that, let's move ahead. So the first question is, what is exactly a design pattern? Would anyone want to take a guess? Mm, okay.
In simple word, it's the best practices like to achieve an objective. For example, this factory pattern is the best way to create the object.
Yes, you're almost correct. Yes, yes, you're correct. So, let's take a look. Because basically, this design pattern have so many answers. If you go and Google search, correct, so you'll get a lot of answers for the same thing. So let's see what exactly a Wikipedia says, and it's what exactly the Vikas just explained right now. So, a software design pattern is a general reusable solution to a common occurring problem within a given context in a software design. So, in simple terms, a solution to the problem which occurs more than once, and in more specific, in a software application. So that it is. And as Vikas just explained, some people also call this as the best practices adapted by the experienced object-oriented developers. So it really doesn't matter if it's about the Python or Java, anything, because these all programming languages are object-oriented programming languages, which can at least adapt to most of what an OOD principles are. So, so that's the reason we need some of the best practices that we are aware of at the moment. So let's go ahead. And I think somewhere around we have 20 to 23 predefined standard design patterns. Okay, and they are broadly classified into three categories. That is creational design pattern, structural design pattern, behavioral design pattern. So before we go in depth about design patterns, I would like to tell you guys that design patterns actually they don't they really are not something like have a specific logic or an algorithm you have to go by step. Okay, it's just that you are organizing your code in a very structured manner, in a very best manner, in such a way that it is robust, and in the future it's for long term purposes. Okay, so that's the main intent of having this design patterns. Okay, so having said that, let's see what exactly are the design patterns that we have. Like I just said, like we have 20 to 25. Yeah. So today we are going to take care of the second part of it. That's a factory pattern, which is a part of a creational pattern. Okay, and yes, these all are creational patterns. They do wonders depending upon the what kind of a problem that you have in your application at the moment. And this design patterns, they actually, it's not always not always mandatory. Like without having these patterns in place also, you can still do the work. The application will still run the same. It's just about the developers, how much effort they're going to put in, and how long it takes for them to make small changes without breaking the existing code. That is what an essence of it. If a developer writes this correctly, that's very sweet and kind of him, and it saves a lot of time in the future. And if we are not aware of this principles and the patterns and everything, if we are not implementing them rightly, it's going to make a chaos in the future terms. Okay. So that's it. And let's see. So today we're going to discuss, like I just said, about a factory pattern. And let's see. And yeah, before we jump into a factory pattern, I just want to ask one thing. I hope you all are aware of what's basics of like what's an object, an interface, and all the terminology, correct? You guys can just write in the chat if you're not comfortable talking, because I'm going to talk a lot about an object interfaces and everything. If not, I can give you a one-liner introductions and everything. Cool. I'm getting yes, yes, yes. Perfect. Cool. Okay, so let's go ahead and see what is a motivation and the bookish definition of this factory pattern. Okay, a factory method is a creational design pattern that provides an interface for creating object in a superclass, but allows the subclasses to alter the type of objects that will be created. Okay. So if you see here, we have three terminologies, that is an interface, superclass, subclass, and alter the type of objects that will be created. That we need to be really underline this 4 to 5 things. In technical terms, it separates the process of creating an object from the code that depends on the interface of the object. So to be very, very in technical terms. So here I put down an image which will help us better what exactly it means. Okay. So if you see logistics, okay, I'll come back to the logistic part later. But yeah, this is in turn what exactly it is. So let me take an example and go in depth. Okay. And let's see how it goes. So let's assume that we are trying to build an application that allows a user to transport the things from one place to another place. Okay. And once the user opens the application, they will enter the source and the destination place and the item which needs to be transported. Post that, it's the application's responsibility to perform the rest of the magic. Okay. When I say the rest of the magic, that basically means the entire the business logic of it, saving in the DB and contacting to the transporters and all that thing. And let's take this example where we have a user A and is trying to transport a mobile phone from Delhi to Hyderabad. He have a personal phone of his and he's in Delhi and he wants to send that phone to Hyderabad. Okay, so let me ask you guys, in how many ways can we transport this one? Can anyone would like to take a guess and say that how will you or anyone can send or the application can send? Hmm, any guesses? What I mean is basically, for example, I'll give you one example. Yes, you're correct. There are multiple ways, different modes. Correct, exactly. There is road, sea, air. Yeah, perfectly correct. Correct, guys. So yes, there are different modes. You can set it by road, you can set it by air, you can set it by rail, you can set it by sea. Now that again comes by road, whether you're sending via truck or you're sending via in person or you're sending in car, blah, 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 whatever it can be. You're 100% correct, guys. Thank you for that. And having said that, there are a number of ways. How would a typical logic or a bird's eyes view would be for this entire application? Hmm? So let's see that in the next slide. Example. So we have this logistics. Okay. So if you see on a very high, like 30 feet high view of this application, let's break it down into three steps. Step one, get the source and the destination from the user. Step two, get the optimized way to transport it. Now, step three is transport the actual item. Okay. So let's concentrate more on a bit of step three, that is the transportation. A while ago, we just discussed that there are n number of ways to transport an item. Well, to be frank, the type of transportation majorly depends on the step two, that is optimized way to transportation it. Okay, let's say that this phone is a very urgent item that needs to be delivered to Hyderabad immediately, like maybe within next 6 hours or so. So depending upon the urgency, you will put it on a flight and you'll send it, and you'll cause the same to the user too. And now let's say it's not an urgent item that needs to be delivered to the destination. So what you do is you put it on a sea mode, probably. You have a ship that going to be next week or something. So since there is no urgency for it, you put it on a sea mode and then it'll go in a month or something, whatever the timeline will be there for that. So the transportation thing is entirely depending on the optimizer way. Post that, it's dynamic basically. You just cannot decide at the moment. It depends upon what a user's requirement is also. Okay, let's assume that we have some part of which is step one and step two, and let's get into a step three. Okay, so here is a small example code for the logistics part without a factory pattern, so which typically does the step three part. We are just going to enter into the coding part of it. Okay, guys. Yeah, there you go. Okay, so now I'd like to request all of you to have a glance at this code for a minute, okay? And then we'll be discussing a lot on this. Okay, guys. So who is done with having a glance at this, 10 to 50 lines of code? Can anyone take exam? I mean, talk about it. What exactly the code is doing? Mm, Maybe Amit, you can unmute yourself and maybe you can talk, not just in a slicing. Yes. Anyone, Amit, Vikas. Okay, yes, the current hard coded for three methods. Okay,
So actually, currently hard coded for two methods, like for truck, transport mode, and ship.
okay,
So
perfect.
in future, if you want to add more ways, for example,
Mhm,
train or something, then we
mhm,
have a problem with this code.
That's correct. So, let's typically, let's say, a very basic engineer has written this code, and then in future, you're trying to put on more ways. Let's say you want to put a bike and a car, and then how can we do it? Probably because.
Um, how can we do? Yeah, we have to create the subclasses and we have to create the interface. But in Python, I don't know how to create interface.
Okay, okay, yeah, we'll get back to that part. So yeah, so basically, yes, if you really don't want to touch the entire part of it, you will be creating more if else ladder. Yes, yes, you're correct, Sayed. Seda. Sorry for the mispronunciation. So yes, you'll be writing more else if cases, and that's how you can do one part. And the second thing, is there anything else that you can see something wrong with the current code? I can give you a hint that it is missing deliver. Okay. Okay. Maybe you can say what exactly deliver, which part of it, because one is delivery details and the third is a print statement where you're actually delivering via method.
Oh, I'm sorry. I just meant the spelling of it.
Oh, okay. Sorry. That's a typo for me. Could be. Please excuse the typos. Change the option in the transportation mode and transport mode to aeroplane. Transportation mode to aeroplane. Okay.
To deliver method.
Okay, so basically it's violating a few of the solid principles. So I'll be covering what exactly the solid principles in the later slides. So here let me just go through what exactly is. It's quite a bit straightforward code, to be honest. You have a class called logistics, which you have a method called create, transfer, and deliver item. And this method have a hash map or a dictionary which contains some basic information about a delivery, such as what is the mode of the delivery, expectation date, arrival, and what is the cost, and everything, all such kind of things. But here in the example in the code, you can only see I in the else if clause, I'm just putting out the method. That's it. In what method it is going, that's it. Now, based upon this transportation mode, either it will go, or whatever the given mode, it will go to the if part or one of the else part, one of the conditional statement. It will be agreed and it will go quite a bit simple. But for starters, everything in this method is going to cause a lot of issues in the future. Like I think because of someone just highlighted the part that if tomorrow there's a new mode is coming up, you have to again write more else if statements and go on and go ahead. And let's say that in this one of the else if statements, something goes wrong and maybe says a null pointer checker or some kind of a checker goes off, and the entire method will be gone. Entire method will be gone, and you can't even, you'll be getting null pointer exceptions. So that leads to the point number two, that everything, there is no segregation. All the work is being done in one tiny method, which is tiny at the moment. But going down the lane, when the application is growing, when the user space is growing, more features are being implemented, this method might have to take up other responsibilities. Here, it is doing two responsibilities, which is completely incorrect. That is one of the solid principles, a single responsibility principle. A single class or a method should perform only one functionality, not more than that. So the point number one, complex logic code. Okay, let me go to the next slide where I have written what are the issues. So one is the complex logic code. My bad. One is the complex logic code, that is the else if nested things, which are really hard to maintain because of a new logic path needed requirements in the future. Okay. Second is the supporting multiple implementation of the same feature. So I just explained you the reason why we need to segregate it, correct? So that is again contradictory to the what? Combining similar features under the same common interface. And the last one, violation of the solid principles. So whenever we are writing any sort of a code in an application, correct? So we have to keep in mind few of the principles. So this is the one basic principles that most of the, oh my God, my system is acting. So that we need to keep in mind. So let's have a quick glance on the solid principle exactly. Okay. So yeah, there you go. There's a solid principle. S stands for the single responsibility principle, O for open close, L for list of substitute, I for interface segregation, D for dependency inversion. So the S basically says that each of your application should have only one single responsibility. That could be a method or inside a class. So if you're saying about logistics, it should only take care about the logistics, but not about the rating or about the user basis. And if when you're saying deliver, it should only talk about the delivery of the item, not about the transportation mode of an item. Okay, so that's the most basic thing. And the reason why we need to take this S principle very carefully is because if you're not segregating the code properly, in future, if you start dumping all the things in one method or in one class, it will become it becomes very large and very, very hard to maintain it. I have seen the code where in one file there's a 20,000 lines of code. And out of that, 50% of the lines are not even being used anywhere in the flow. But still, they are just there because nobody had any time to clean up the mess. So that is the reason we have this principle, standard principles, where they see that you're not supposed to write more than 14 to 15 lines in one method and not having more than 1,000 lines of code in a class or sometimes. So now that drills down to the organization that you are in and what kind of coding guidelines they are following. So that's the importance of S. Going to the O, that is open close principle. So a software module, it can be a class or method, should be open for extension but closed for modification. Any of it, you should let the other classes or other methods call it, okay, and build an other logic on top of it, but you should not change the entire logic of it. I hope you guys are aware of this OOD principles, correct? You guys are aware of it, correct, guys? OOD principles. Let me type in the chat. Perfect, perfect. So one of them we have inheritance, polymorphism, and all the things, correct? So, hey, so someone said no. Okay, guys, whoever is not aware of the OD principle, please let me know because I'll give you a quick glance. It's not there in the slides, but I can talk about it quickly for 5 minutes so that you all will be in the same page. Okay, I get one more no, Meghana. Okay, cool. No, no. Okay, we have a lot of people. Object-oriented design. Yes, yes, sir. It's sort of a yes. Okay, so okay, let's me do something like this. So basically, we have this OD. Okay, okay, okay. Let me ask this because we basically need inheritance. Does all of you are aware of the inheritance principle or the feature of it that we get from the OD, object-oriented design? Yes, perfect. Yes, yes, yes. Okay. Anyone who's not aware of what exactly the inheritance means in object-oriented, guys? Okay, let's go with an yes. I have no news so far, so I'll talk about it later. Okay, so, okay. This extension is basically is that. So you basically inherit or you call that particular. So you have multiple classes and multiple methods. So what the O principle says that you can call that particular object and you can update, you can write more on it later. Okay, but you cannot change it. You cannot allow any other classes method to update in some other place. Okay, that's an overall it basically means. Going to the Liskov's, the Liskov substitute principle. Objects in a program should be replaceable with the instances of the subtypes without altering the correctness of the program. So I think this principle, I feel it's more and more apt to where you have, Java sort of a thing. We can still put it in Python also. It's not that we can't, but it makes more sense over there because there, you have a better understanding of what is an abstract class and interfaces and all that things are. So I'm not going to go in depth about the L principle, and I'll quickly jump on to I and D principles. I is interface segregation principle. Again, the client should not be forced to depend upon any of. So basically, what it basically means is you have to segregate. All the things are not supposed to put in one interface. You have to differentiate the interfaces too. So in normal term, okay, next is D principle. Yeah, so that is one of the most important principle as is dependency inversion principle. So what it basically means is program to the interface, not to the, okay. Someone, okay, different interface for each functionality. Okay. Mm, sort of, yes. I think someone just asked a question. There's different interfaces for each functionalities. Sort of, yes. You should never put all the methods in one particular, uh, in one particular, uh, okay. You should never put it in one particular method or something like that. Okay. So let's assume that you have one interface which talks about user databases or related to user profiles, and one database or one interface which talks about logistics. So, what basically IE principle says that you should never put all these methods into one interface, saying that application interface or something like that. The reason for that is majorly is what I feel personally feel is in this Java and C and all this interface when they say what it basically means is it just have a method name but no body is written. You have to implement this interface to some other class, and then you have to write the bodies for each of these methods which are there in the interface. Okay. And when you're trying to write a code about logistics, there is no meaning in writing again the bodies for the user profile or user databases. So that is the reason the I principle talks about segregating and writing the respective interfaces to the respective functionalities. If it is doesn't work under logistics, you shouldn't be putting in the logistics interface. As simple as that. Okay, I hope did I answer your question? What are the different interface for the each functionality? Okay, multiple parameters from the same method. Amit, I didn't get your question, Amit. Okay. Each client can have different interfaces for same functionality. Or could be. Now that entirely depends upon the okay, answer to Vikas's question. That is, each client can have a different interface for same functionality. Hmm, that is not recommended if you ask me personally. Like if you have one functionality like calling and okay, let's take this functionality where you're trying to do a delivery. Acha, okay, okay, thanks, Amit. Understand. Okay, so let's take this one example, Vikas, where one of the feature is you're trying to put a delivery plan for a given source to destination, and whatever the related methods and everything, you're going to put in one interface. But it is never restricted that you should not put the similar things in multiple interfaces. You can do it. There is no harm in that. You can put on some interfaces saying that maybe you know there is a way to implement in different ways with different parameters. Yes, you can. You can always do that. But my personal suggestion is if we drill it down more and more, it will become an over engineering issue. So at times in big organizations, they also face this issue called over engineering. What will happen is basically in terms of this having different methods and different parameters, they start putting in different files. So rather than having like five methods and in one interface, if you start putting one in each interface, or let's say two in one interface, saying that this is about road or this is about sea, this is about air and everything like that, what will happen is the maintenance of these files will be gone. Let's say that maybe for some region tomorrow going ahead, this application of ours is not supporting by air anymore. Like maybe all the flights have been cancelled and the only way of transportation is by road and by sea, depending upon the geological location. Okay. So having said that, tomorrow you are disabling that particular feature to that particular part of the code. So in that case, this part of files, who is the new is going to remove it. But who's unaware of it, he don't know what the other files are going to do. So it's best to keep the things which are, related to in one place. So is what my personal suggestion is. If we start doing it more and more, it'll be more chaos in future. Okay. I hope I answer. Did I answer your question, Vikas? Got it. So yeah, one more principle that I really want to tell you guys is that is D, that is program to the interface, not to the implementation. Uh, we'll talk about that later if we have some time, because right now I will show you what exactly is I'll show you next is what exactly the factory patterns class diagram is on depth. Okay. And then probably we'll have a quick coding session where I'll be coding the given example, in terms of with factory pattern. Okay. Let's go and see factory pattern. Okay. Here is an overview of a factory pattern. Well, the client will come. So he will ask a new object, returns a new object. Okay. So let me go back few slides and ask you guys that can any of you put this particular code, this 4 to 10 lines of code with respect to this? Can you try to do one-to-one mapping, which can be a factory method, which can be a class, which is a client over here? Anyone? Hmm. Any guesses, guys? Repeat the question. Okay. So here I am showing right now is an overview of a factory pattern. Okay. So I want to ask you guys that can you put one-to-one mapping between the previous code to this pattern? How can you include? So here in the pattern, you can see there's something called factory, there's something called I class, and something called class A, class B, class C, implementing, and all the blah blah things. So can you map it? Is any intuition coming to any of you guys that maybe this part of the code I can put in factory? Maybe this part of the code I can call it as a client. Maybe this part of the code I can put as class A and class B. So here is the code, and that was the diagram.
So maybe with the if statements, those could be like class A, class B, and class C.
Mm-hmm, mm-hmm. Okay. Okay. Uh, who the man just spoke right now? Why do you think that can be a class A and class B? You're trying to put like the truck entire method is into class A and class B, something like that?
Yeah, just because I'm seeing like different like the different transport modes, and we're trying to make that into one thing.
Perfect. That's a really correct answer. Yes. Yes, that's class A and class B over here. And someone here responded. Client is calling the class method, and the interface is respective classes under the factory pattern implementation. Yes, who wrote this? It's a very high level. Can you drill down a bit more? What is it, the client in that 4 10 lines of code? I transportation, C truck. Yes, you're exactly correct, because that we have something called the I class is a transportation, and then as the other ma'am just spoke right now, that the class A, class B would be the truck, ship, and tomorrow maybe more bike, car, and whatnot. So my question is that what is going to be a factory and what is going to be a client? Any guesses about the client and the factory? Here is the which part of this code could be a client and which part of this code could be a factory.
Maybe like the ending part, the L is equal to logistics, and then L dot create transport and deliver item truck.
Oh, perfect, perfect.
Yeah.
You're absolutely correct. Yes, client is the main method and factory would be the main method. Uh, to be honest, we really don't have a main method over here, guys. So, yes, if you're claiming that client thing, okay, create transport and delivery item, something like that, guys. Okay, perfect, perfect. Okay, I understand. So yes, we can claim this logistics into the client, and then as we said discussed earlier, we can get the truck ship into the subclasses, that is classes A, B, and C, and you're claiming this entire basically function into one big factory method. So, okay, let's go. I'll be coding. You guys will be seeing my screen while I'll be coding, and then you can suggest me more what exactly and how exactly we'll be coding ahead. Okay. Uh, 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 Give me a moment, guys. I'm just opening my editor. What am I? Mm, Okay, perfect. We are done. Let me get down the code. Okay, let me know once you guys can see my screen. Okay. Chat. Perfect. Yes, we can see. Perfect. So as you can see here, I just copied a part of like without factory pattern code which you were seeing over there. So is this font size is enough, or shall I increase the font size? Mm, I'll be increasing a bit. Okay. Let's see. I'll be commenting this code at the moment. Okay. I'll just try to write it with respect to with factory pattern, and then I am going to comment this because that's really not required. Okay, so or let me take the most basic things and then I'll comment it out. Just copy paste the same thing. So at the moment, I have commented out the init method. Init is the constructor. I hope you all are aware of the constructors, correct? So when you call this particular, this is the first thing would be running, and it's not compulsory to have an init method. It's up to us if you want to have any, predefined set of things. So I mean, I'm not executing the entire application. I'm just going to tell you the step three, the transportation, how exactly we can convert this particular method with the help of the factory pattern. That's it. So that's the reason I wrote some default code and then I have commented out because you cannot have any function without any code here. Okay. So let's go here and then that's really not. Yes, you're correct. This is entire client part. We are not going to go touch anything. This is the client. Okay. And yes, this is the calling method. Now, can anyone help me with the classes? How shall we create the class A, B, and C? Should I create a parent class and do something to that, or any guesses, guys, or any suggestions? Anyone? Mm-mm. Okay, I think, okay, let me take this one. And okay, let's basically what we have to do is we will be creating few more classes. That is this, the principle as one class or method should do one responsibility. So the logistics should really never have anything related to the transport. It should only say deliver this item, that's it. So it should have its own internal subclasses and methods which actually takes care of all the other transportation and things. Okay, let's have a class called transport. Okay, and this is and here, oh, let's have some init method. Okay, and then say, well, a transport item will just do a deliver. It will just blindly delivers the item from A to B. deliver, and then I'm not going to say anything. It's I'm not putting all the parameters, and yes, I'm just saying gonna say print delivers the item in the default way. Okay, that's it. And next, what I'm going to do is, what I'll be telling is I need to create now different transportations. One is, let's say, by road is a truck, and maybe next is a ship. So let's go ahead and make a class of truck transportation, truck transport. Okay, I'll be pasting some part of the code so it just avoids my typos and everything. And then I will be delivering again the same thing with the help of a truck.
Hey, hi Anupama. Sorry to quickly interrupt. Just one question quickly. I joined a little bit late. Why exactly do we need this this factory pattern all the time? As in, is it a necessity just for performance or debugging? Is it?
Actually, okay, so your question is why exactly do we need a factory pattern, correct?
Yeah, I mean, do we need it because we'll have a debugging nightmare sometimes, right? When we have a long, complex functionality to implement. So I'm just wondering. I mean, I'm currently facing a similar kind of problem, so I don't know if they are related. I'm just trying to connect something here.
Understand. So can you see this upper code which I just commented out here? If you see from line number 7 to 13, what it's basically doing is you have one particular object and you're trying to update the same object. So here at the moment you're just updating one method, one part of it. Like in this hash map, just one key. Let's assume that it's not one key. You're updating 10 keys over here. Okay. Let's say that you have updating 10 keys. Okay, and then
We
here,
mean a dictionary, right?
yeah,
You said.
dictionary or hash. Yeah, you're correct.
Okay. Sorry. Yeah. Because.
Okay, and let's assume that you're updating 20 keys here. And out of that, these 10 keys are very specific to only C transportation. Okay.
Okay. Yeah.
So
Okay.
what will happen is basically, even though these 10 keys are nowhere related to the truck method, but yet when you're trying to send this object to the further flow of your application, you still have to send it, which is completely irrelevant, but still you're doing it. So this is what is the maintainability of the code. Like you said, at times you
Okay.
encounter
Okay.
debug and
Okay.
everything, correct? So will be recording. I think the host of this meeting can answer your question. Is LearnBay is here? Yes. So
Yeah,
there's one.
yes, guys. Yeah, recording will be available.
So answer to the earlier question. So
No, I mean, Anupama, see,
yeah.
basically, Anupama, debugging would be a bit of a nightmare. That's why, because we have a, Salesforce application that
Okay.
we are commenting, we are coding it, and then that is where the order, shipment, and everything is. It is a bit of a nightmare. I'm not
Yeah.
saying it is total nightmare, but how do we actually benefit from this? Then I will transfer it to my team, saying that okay, these are the benefits maybe.
Okay.
So I'm
Can
trying
you
to
please?
understand. I don't want to
Okay.
take much of your time. Just want
No
to.
worries, sir. Please ask your questions because designing is one aspect where we can, I mean, one person can't talk all the time. It's the other person who have to ask questions. So maybe you can talk a bit about your problem. Then I can tell you which kind of a pattern would have helped you and not exactly gone into the debugging life cycle.
Okay, so kind of like when I have a 6 guys who are looking after actually the coding aspect, and they are kind of I have a QM who's sitting on my head
Okay.
because of the coding quality standards and all that. So I have to justify why we are doing this. Basically, I've told my team to follow this pattern. They're doing it in Java, but this is similar in Python. Let's not go into the scripting language.
Yeah.
But they're doing it in Java, but the justification has to be there why they are not following the normal
So
pattern of doing it
I
rather than
can
going for
talk.
only of.
Mhm. Understand. So basically, there are multiple creational patterns. Okay, so there are behavioral patterns. Now I can categorize your issue either as part of two things, either a behavioral or it is like whether this design patterns you can put also for the strategy implementation. How exactly you're implementing the strategy. So that's that. So in terms of Java, if we speak, you have an object and then you have some of the predefined the fields, correct? So
Correct. Yeah.
correct. So I'll give you a very high explanation. If you're, can you take this question later or offline? Okay.
Okay, sure. We can take it offline. No problem. I'm
Let's take this
probably
question at
don't want
the
to
end.
waste the time. Yeah. Yeah, sure.
Okay, perfect. Let's take this question at the end. Okay. So going ahead, I'll quickly complete it off in next half an hour because so that you don't miss the important part of this session, that is the coding into the factory pattern. Okay. So let's assume that you have truck. Now, I would like to ask any of the guys that at line number 38, what did I do? Is it the same as this or is it slightly different? Let's say this is a sea transportation or say ship and items come from truck. It was the item in the truck or roadway. And okay, I would like to ask you guys quickly, what is the difference between line number 38 and 42? Anyone? Okay, correct. Yeah, missing in 40. No, there's nothing missing in 42. 42. Oh, basically 38 and 42. Yeah, 42. Yeah. Inheritance. I think because is the guy who just replied. Yes, that's correct. So basically, when you write this transport in this parenthesis, that basically means that you're having an inheritance in Python. So what exactly inheritance means is, this particular class is a subclass of this class. So whatever the methods are there in this, you can inherit to this particular transportation. Plus, you can have their own dedicated methods too. So and you can also override. There's a concept of override. So when you are having inheritance, you can override the existing method. So let's assume that tomorrow you do not have this deliver method implemented in your subclass. So when you do a truck transportation dot deliver, it will deliver via default. So it will not get executed the line number 40, 39 and 40. It will actually get executed with 35 and 36 because truck transport is a subclass. It's a baby of the main. So this is more of a parent and this is a child. So that's how it goes on. So, but if you have your own particular definition, that will be getting executed again. Okay. So let me make a ship is also a subclass with the transportation. Okay. And why exactly is it throwing me an error? Unexpected indentation. Okay, I'm really not sure. Okay, I understand because there is no code written over here. We will be writing the code over here. So this is the first part to what we have seen in the slide, that is classes, class A, class B, and class C. So this is the main class, that's a parent, and we have a class A and class B. Okay, guys? And let me know if you have any doubts. Please write in the chat. I'll take it up in the later. Okay, I'll quickly complete the coding part of it. Now comes the heart and soul of this method. That is the transportation. Sorry, no, that is the factory method. We need to implement the factory method. So let's quickly go and write the transportation factory. Transportation factory. And let's have some init code. I really much not interested. And then say get def get transport. So this method is purely concerned about getting the kind of a transportation. That's it. It really doesn't care about how exactly it's going to deliver and all. This guy is only give you what is the mode of transportation that is going to have given the transportation mode. Okay, self and then transportation mode. So again, to some extent, we can avoid this if else. In some cases, you can't. You still be having nested if else, but I'll be talking about the nested if else, how it is preventing from the without factory pattern code to the with factory pattern code. Okay, let me just get this thing right. Truck return return or truck transport, else return or ship transport. Okay, so this is the last step of this implementing this method is patching up all the things. Now you have your classes. Now you have your factory method. This is our factory method, and now you're going to call the client. The client is going to ask for an object, and it's going to do some more. Okay, so instead of putting everything in one, what I'm going to do is I'm going to have a transportation method. Okay, I'm going to call my transportation factory. Okay, and say get me the transport. Get the transport given transportation mode. Post that the t.deliver will do the work. Now, so yeah, this is the entire code of it. So then with these two lines writing over here, you have a working code at the moment. So if I call create logistics l dot create transport and deliver, a truck is the mode. What it will do is essentially it will come here, it will call the factory method, and it will ask to get the transport. And when you're asking to get a transport, it will go into the nested if else and give you back that particular model. Understand, guys? So a quick question to all of you is, how is it different from this nested if else? Can anyone guess it? Here we have a nested if else, correct? Remove this line. No worries. Can anyone guess exactly how is it different from this nested if else to this nested if else, guys? Anyone? Maybe Vikas or Amit or anyone? No. Okay, so basically here in this nested if else, what you're doing is you're updating the current object. Okay, so here I was talking about here we're returning an object on the fly. Yeah, exactly correct, Vikas. So that is the reason why it is a creational design pattern. You're creating the object on the fly. You're deciding it and you're returning it. And also you're following one of the solid principles where you're actually returning a subclass to the to the parent class. Here, the T transport is actually is having a capability of having any kind of a class. It can take it up. So let's assume that if initially you're putting T as a transport, and then in that you're returning this particular truck transport or ship transport, that will still be working because this is a subclass of the major class. So that's all the OOD is. That is the reason that we have, and it'll never get any sort of an error, runtime error ever. So what it basically is doing from here to is you're not updating all the things in one particular dictionary, rather it have its own class. If you ever print this dictionary again, it will come with a key value and everything again. If you have your own init method, some init, like the basic thing is will be common, for example, the methods and all the things, and remaining you can add. Probably in the truck transport, you can have the init and add, or maybe you can have one more method and add how many kilometers it has been running, and in ship maybe you can add that number of days it will be taking for the ship to transport and all this. The dedicated details will be only to the dedicated classes, not any extra or unused things will be entering. Okay, with that this updation of the keys problem is being resolved. Here you're returning entire object and you're not doing anything else, whereas here you're actually altering some data. So that is the gist of it, that pattern. Okay, and then again the second principle, single responsibility principle. You're not doing all the stuff in one place. You have respective factory, you have respective classes to do their work. Okay, and then you're calling t.delivery. So this t.delivery is really not concerned about what kind of a delivery that you're going to do. Whereas here in this case, in the future, you're going to update the delivery details, maybe in some other chunk of the code, which is again is going to throw you an error. So maybe if somebody forgets to put a null checker or any sort of a checker, then the entire code will be going for a toss. Your entire your feature is going away. So that's how we're going to save our day with the help of these kind of a classes. Any quick question to any of the guys over here? Anyone? No. So did you guys understand exactly why we are using a factory pattern and why is it really important?
Sorry, this is Saida. I just wanted to clarify.
Yeah.
I understand. So I think I understand that, you know, there is a parent and then you have the children.
Yeah.
But the reason why we're doing it is because once you segregate it, then you can add more details within the subtopics, or like the sub.
Correct. Yes,
Okay,
yes. Yes,
okay,
you're
okay.
correct. So
Thank you.
basically, when you're creating their own dedicated classes and you have your own things, correct? So in that moment, you're not messing up with any extra information. So at times, some part of the information is necessary for the further flow, okay? And if you're not providing it correctly, you might enter into some kind of an issue, okay? So that is a problem with this particular code. If all the if-else clauses, if all the clauses are touching one object, and if one of the things are not actually having a method or trying to introduce something else, and it throws an error, so you will get an exception here, and maybe if you write a try catch, it will immediately go to the catch. Whereas if you have this dedicated part to it, you're segregating it. So I hope you understand. So one of the guy just explained like how is having a troubles with the debugging. So it really helps you with the debugging purposes. And a logging is also one important key. So you can put more loggers over here, like which kind of an object has been returned and all the things. So you can catch the errors well before. And let's assume tomorrow if you're getting a new transportation, say maybe air. So all you have to just do is write one more if else and just return that particular method. That's it. That particular class would be written. So let's assume that tomorrow it's maybe with a you know with air transport via air. Let's make it funny. And then let's say here, all you're going to do is introduce this new class, which is not touching any of the existing code. And all you're just doing is you're just writing one more else if clause. Uh, and then you're going to return this particular transportation. And there's also one of the backup to this is if you do not even write this particular method, the default methods would be getting executed with this. So yeah. Anyone have any questions upon the factory method? Okay. Thank you, Sayeda. Anyone? Any more questions that maybe we could have segregated it better or we could have done something else? No one? Okay, so that's a bit about the coding part of it. Let me quickly go through my slides and I'll explain you a bit more on that. Okay, there are a few more slides left off. Let me share my slides. Share. Okay, so can you guys see my screen? I'm sharing my PPT again. Okay, let's implement the factory pattern into this code. So let's find the introduce the required classes object rather depending on the dictionary or hash map. And then the second step that we have already done, let's try to use the OD principles as much as we can. In this case, let's have the inheritance in place. And then let's have a factory method which acts as an interface, which in return takes care of creation of the objects rather than updating any of the objects. So that is what we have just studied in the solid principles, that the D principle is you should never extend like have a sign off now. Thanks, madam. Thank you so much because you have been a very kind patient. Thank you. Let's go ahead and let's continue with this. Okay. Creation of the create the required object. So as we have just coded, the transport is the parent and the truck and the ship is the respective the child classes for it. So the classic inheritance implementation that we have implemented, and going ahead, we have transportation factor, which is actually an interface. Okay, so I'll just I'll just summarize what exactly that the factory pattern has done is that we have a superclass with the multiple subclasses, and based upon the input we return one of the subclass. This pattern takes out the responsibility of instantiation of the class from the client of the program to the factory class. So this is the entire factory pattern does. So does anyone have any questions on this, or shall I go ahead? Any doubts?
Sorry, this is Saida again.
Yeah.
With like I understand like the parent and the sub and the children. I
Yeah.
don't get like so if the parent wasn't there, right? It
Hmm.
looks like it might have the same effect. Like, can you tell me like you know like what like how does it help having the parent there?
So you're asking me if even if I don't have this transport class and still these two classes would have done the work, correct?
Yes.
Yes. Okay, let's assume tomorrow that you have implemented your, one of the new feature. Maybe in the next release of an application, we have release cycles and everything. You try to invent, you're putting an air transport also via flight or via some sort of a air transport, maybe by a helicopter, you're sending it. Okay. But you haven't decided yet, like what is the timeline or something like that. And you do not, the transport is available, but it is not at the moment open. At times we have seen in the applications, correct? Some feature you can see it's so coming soon or something like that. So in that cases, you cannot put a delivery method. Do you agree with me, Saida?
Yes.
Yes. In that case, what do you think what will happen? Because if you see our client method, it's going to call the transport and it a flight air transport method would object would be written. But if you do not have a delivery, what will happen to this particular line? What is your guess? Will it work or will it throw an error or
Oh
what is
yeah,
it?
it would throw an error because
Correct. It will
because
throw
it doesn't
your.
recognize it.
Yes, yes, that
Okay.
is the reason of inheritance over here. So even if you're missing out on the basic things, the base important classes, the parent class will have it and it'll do it. So in this case, it'll say it'll fly where deliver the basic things, or in the later part of the code, you can handle it. Like saying that if this is what is the, you can have flags. Which will be indicating, and via flags you can say that okay, this is the reason. You can say the user that no, it is not available at the moment. But if you don't have anything, if you're not, if you're calling dot deliver and it is going and searching the deliveries, if inheritance is not there, it will fail at this point itself. So that's the reason that you need to have a parent and then you can have your own child classes.
Okay. Thank you so much.
You're welcome. And also one of the reasons is at times in a very big application, it's just not one developer who's working. There are 5 to 6 developer constantly working on the same file. And if they're really new to the system and they're not aware of the system properly, they might end up causing new errors. So that is where also inheritance helps a lot. If you have the default methods, you'll never encounter a error easily. Okay. Okay, so coming to the part again, create the factory method. Yeah, we have this factory which will return instance of it rather than modifying any of the data. The factory responsibility is just to return an object. That's it. It is not going to tamper with any of the data, which our earlier code was doing. And this is the very basic thing with the factory pattern. You're just delivering the things done. So let's have a quick glance on advantages of the factory pattern. So the very first advantage is it provides an approach to code for the interface rather than the implementation. So earlier when we say rather than to the implementation, that is the changes of that code. Okay, let me go back to this part. Okay, here you have a delivery details, which is a dictionary to which you are changing in every if else clause. So this is something called writing to the code to the implementation. You have defined, you have initialized, now you're changing the things inside the subsequent code, which is in implementation. Whereas you have an interface, you're writing this, and then that written object will be doing the rest of the work. So that is called writing your code to the interface rather than to the implementation. So next advantage makes more robust, less coupled, and easy to extend. We try to decouple the things as much as we can so that in the further in the down the line, if somebody is new and then they want to debug and learn the system more, it will be very easy for them and then easy to extend. Yeah. Now, like I just showed in the earlier coding example, where if you really want to add a new way or new feature or new way of transportation, it's just the matter of fact. You're not touching anywhere the current code. So you really don't have to even test that part of the flow, whether it's breaking any of it. Whereas let's assume that if this is the earlier code is there, and if you're writing an else if clause and if you're changing delivery details, you again have to test all the if clauses. You never know at which point what will be breaking off. So it is saving your time in the testing and also a less bug prone thing. Okay. And coming to the next, abstraction between the implementation and the client class through inheritance. Correct. So this is the same thing which I explained for the Saida and also the rest of people. It helps us in getting the abstraction also, which is also one of the principles of OOD. Okay. Any questions on the advantages, or do you want to explain with any more examples, guys? Anyone? Okay. Let me go ahead. Okay, so here is the conclusion to this particular the factory pattern is the factory pattern is widely used and one of the most creational patterns that can be used in many situations. Okay, I just explained you one situation. I can talk about more situations where we need to take the concrete implementation out of it and put it into the respective code. So when I say the concrete implementation, that again means the implementation is inside the changing of the delivery details. That is the concrete. You're hard coding it. So yes, and then the second is the most important thing. Why we exactly need this is because changing existing code can introduce changes in the behavior and the subtle bugs, which is a very nightmare to the any developer who's new or also into the system for a very long time. Sometimes these bugs are very, very crazy. So writing, spending more time before you introduce the bugs is what we developers follow our best. That if you're given like 100 hours of time to develop an application, they try to put 90 hours in the planning and the designing part of it, and the 10 hours in writing the code. So what you're going to do in 90 hours is this is what you're going to do. You're going to take all the positions and then you pick all the parts and you try to put into the different patterns. And the third and the last one, the pattern removes the complex logic code that is hard to implement and replaces with a design that is reusable and extensible. The pattern avoids modifying existing code to support the new requirements. So this is what I was just talking, that you really don't have to touch any of the existing code. So that's how it saves the life. So well, my closing statement for this pattern is again, we have a superclass with multiple subclasses based upon the input. We just written one subclass. That's all is a factory pattern, my dear people. Okay, any questions now? We are done with the screen share has been stopped. Yes, because that's the end of the factory pattern presentation. I will be happy to answer the questions if you guys have any. I think one question is still there, which I forgot his name. We were talking about how exactly it helps. Apart from that, any other questions, guys?
Wait, this is Saida again.
Yeah.
So how does like I'm just not familiar with how you use Python within the AWS infrastructure. Can you talk more about that?
AWS infrastructure. Maybe can you talk,
How?
tell me exactly what exactly in the AWS that you're looking out for?
Like I guess I'm just trying to see I'm just trying to figure out when you would use this in AWS. Like is it would it be like with CloudFormation or I just need an example really.
Mm, well, I think AWS infrastructure is mostly based upon I think what is MAC architecture. MAC is a model view controller architecture. Is my understanding correct, Saida?
Yeah.
Yes. So in okay, model, view, and controller. I think this can be implemented in the controllers because eventually model is the one which will be displaying or showing off the data. View is the one who is sort of a like a interface that gets the data from the controller, and via controller you again go to the business logic. So this sort of a structure is put on the business logic, Saida. Okay.
Okay. Mm-hmm.
So anywhere where you're seeing a lot of if else, correct? I can simply suggest that you can always put in a lot of if else where you're changing multiple things, multiple variables or dictionaries and anything. That is a very good place where you can implement this factory pattern.
Okay, okay, perfect. Thank you.
Anyone else, guys? Anyone have any doubts? Hmm. Okay, I think the one who just asked us the question, are you still online, sir? I see some people dropped out. I'm really not sure if that guy is still online. I don't think so he's online anymore. Okay, so does anyone have any more questions, guys? Okay, so if you guys don't have, how shall we take it ahead? I think we are left off with more 15 to 30 minutes. Shall I talk about maybe any DS algo, or shall we discuss more about any architecture or any design pattern?
I mean, I don't know about everyone else, but I would love to see like another example.
Of this the same thing?
Yeah, it was very clear. But I would just love to see another example.
Okay, that's perfect. Let's take one more example. Okay. Okay, let me think quickly. What can we do? Maybe a shape or something, or maybe. Hmm. Okay, probably we can take this. One more example is probably where you are talking about music system conversion, something like that. Okay, let's take this. I'm making this on the fly. So let's discuss. We have this application where you're converting a song. Okay. The song can be converted into two forms. One is JSON, one is XML. Okay. So in turn, when you call and say convert, and that depending upon the input, the object should be created. So okay, let me share my screen and let me put it down so that you all will be in the same page. Hmm. Oh, by the way, I didn't run this code, correct? Yeah, it is there. Okay, guys, I just executed the code. I forgot to execute the code. That's fine. Let's move ahead and take this example. Example number 2. That is we have a song. You can convert this into two forms. That is convert in the following ways. And one is XML and second is JSON format. Okay, so this is entirely into the backend. I can think of that when you're trying to convert, all you need to say is convert, and then you're going to give the type is JSON, is it should do the work. Okay, the result. Result should have. Okay, so can anyone guess what would be the three parts for what is the client, what is the factory method, and what are our classes? Anyone would like to take a guess? Please explain the inheritance part of the example. Okay, Megha. Okay, Saida. Yeah.
Oh, sorry, I was gonna say. So I think the I forgot the class A and class B. Class A would be like converting it into XML, and then class B would be JSON.
Perfectly correct. And what would you think was going to be the factory part of it?
That first part where the song is converted and like converting the song.
Maybe like an if else clause or just writing some method and with some logic. What do you think in the factory method we're going to put?
Oh, I'm assuming the if else clause.
Okay, perfect. So let me write this definition of a factory method, factory design quickly. It will help all of us. Factory design is we have a superclass with multiple subclasses, and based on input we need to return return one of the subclass. Okay, So this is essentially the crux and heart and soul of the design pattern. So like just Saida explained, this would be the subclasses, and the factory would actually contain the if-else clause, which is the responsible T of the factory pattern to return that particular subclass. So having said that, let's just quickly create the two classes. Classes. Okay, let me just comment out everything, or else it's going to throw a nice error to us. Okay, and let's do this. Classes, XML converter, and before that I need to create a parent class, class converter, okay, and then you can have a def, maybe init with some default code. Okay, now I'm going to comment out this too, because we really don't care much about the init, and then say convert is the main method. Self, and then say print, file will be converted in default okay, and then in the XML converter you're going to pass the parent class, okay, and let's copy paste the same thing and call it in XML format, and let me copy paste the same entire class and just rename it by calling this JSON converter in JSON format. Okay, so yeah, that's pretty much the part of it where you have a class, a superclass, and subclasses. Let me quickly create the class converter factory, converter factory. Okay, and then you have this init. I prefer to have an init in most of the times, but it's just that we don't have that much time to initialize all the objects. So I'm putting in comment, but making sure that is there. Having constructors sometimes helps, is what my personal experience tells. Yeah. Okay, and then we'll have if other self and the mode. If the mode is double equals to a JSON or return JSON convert, else if mode is double equals to an XML, return or XML else print. I have to create one more default method. And now the last part of it is class song converter. What did I write over here? Create. Okay. Def transform the song. Transform song. Transform format. Let's say transform format. Okay. And it takes the mode. So I have an S, or let's say F. I have a converter factory dot get converter for the given mode, and then say F dot convert. And let me write the client part of it. S equals to converter and then S dot transform format into an XML. So, Saida and everyone, are you guys able to follow what the code I have just written at the moment? Does it make sense or did I lost you guys anywhere in between?
I feel good about it. I think it's just like the ending that I was just like that part. Like I understand the client part, but I didn't really understand it.
Okay, which part at the ending? Maybe you can tell me the line number.
Yeah, 120.
120. Okay, so this is the major class. This is the client part of it. So this is the one whom you're going to call the song converter, and then you say s dot transform the song to what? To a JSON format. So here, this is the guy who is going to call a factory and tell which method he wants, and then that particular earlier in the first part we have seen this logistics example, correct, Saida? So here you're putting everything in this one method called create, transport, and deliver item, correct? So rather than that, this is the heart and this is the client who's actually requesting for an object. So you have seen that context diagram, correct? You have a client who's requesting for an object and then you return an object. So this is the client part you're requesting. The factory has been called over here.
So then, why on line 127 we are going with JSON and not XML?
Line number 127.
Mm-hmm.
Okay, so what's your question again? Why exactly here we are going with a JSON and not with an XML?
Yeah. Mm-hmm.
So this is basically is a dynamic thing. Now that depends upon maybe the user A or maybe the one of the feature requires a JSON and maybe other feature requires a XML. So what you usually do is Saida, that this is there in the file A, okay? Maybe in some file A, and in class XYZ you need the song to convert into a JSON. And maybe in some other file B, you have a class of ABC which requires it in the form of XML because that's how maybe it's going to save, or maybe that's how the player is requesting for. Okay, so this is an external thing. Did you get my part, Saida? So it's really so it's not like all this whole part is going to be in one place, and these are the people, these are the actual users who's going to use it. I mean, when I say users, it's not external user, it's just that the different classes and the different methods who are dependent upon this code. When you're writing this much, it's not going to just stay to this part. And I think did I answer your question, Saida, or you have still any doubt?
Yeah, that makes sense. Thank you.
That makes sense? Okay, perfect. Megha, I think you also asked the question, like, please explain inheritance part of an example. Did you understand what exactly the inheritance is doing in this part of the code from line number 89 to the 109? Mm, there, Megha. Mm, mhm. Yes, ma'am. So,
the class converter is there and the function you use for the convert.
yeah,
Hello?
I didn't get your question. Can you repeat again?
I was asking the inheritance part of the example that you are using this converter over here, the class example. So how that is inherited?
Okay, so if you see in line number 96 and line number 103, we have something called converter, which is going inside the parameters. Do you agree to me, ma'am?
Yes.
So that's how you implement inheritance in Python. So let me take it out from line number 103. Okay. And so right now, this JSON converter is not a part of this converter. Okay. And let me show you with an example how exactly it's going to affect it and why the inheritance is required. Okay. Let me just put this thing into a comment and let me just give it a quick run. Okay, perfect. Can you see here in my console that file will be converted in XML format? Can you see, Megha?
Yes.
Yes, correct. Now, since this is the inheritance. Now I have removed the converter from line number 103, and I will just call, maybe some other class is trying to convert into a JSON. That is line number 31, 31, and 132. What do you think is going to happen? What is going to print in my terminal? Any guesses? Oh wait, let me update this thing. Yeah, I have updated. Yes. What do you think is going to happen? I have made one tiny change, that I have made this convert to converter. Okay, or maybe converts. I made convert to converts. Now, what do you think happen here when line number 132 will be executing? Any guesses? Anyone?
It might print out 2 lines,
Mm,
or
do you think it will run it successfully? The entire file will be running successfully, or do you think anything will be surprises will be there hiding? So let me go through like a debug mode. Like you have a song is, you're getting instance of it, and then you're saying transform the format to JSON. So the moment you call that, it will come to the line number 122, and it will call the factory, and it will get the converter. So since the mode is JSON, the line number 116 would be written. That is a JSON converter instance. And then you're going to say f.convert. So this f is basically is a type of this JSON converter class. Can you see any issues over here? The convert and the converts. Anyone?
so would it have an error because it's 2 different things?
Exactly. You're basically calling something which is not existing there. So definitely you're going to get a nice error on our faces. So let me just run this thing. There you go. Attribute error because JSON converter does not have any attribute called convert. That is the reason, Megha, that we need an inheritance. Now, in the same case, if I make this JSON as subclasses of converter, you will not get this error anywhere. Okay. So I have just copy pasted again. I have updated line number 3 with the converter inside the parenthesis, and I'll just run again. You see, the file will be converted in XML, and here you'll be converting in the default way.
Okay.
So
For
the
the converts you had used, right? The dev converts. That also won't give any error, right? Because that is we are defining the function and using it the other way, right?
I didn't understand your question. Can you repeat? Your voice is very low, Megha. Can you speak a bit louder?
I'm asking that the converts function you have created, right? Defining the
Yeah.
converts function.
Yeah.
Since we are using it where?
We are not using anywhere, maybe somewhere some other method. So when you have one class that not essentially is always going to return this, in a typical application one class might be having more than 30 to 40 methods also. So this is some helper method which will you called by someone else, not here, not in this part of the feature. Maybe some other part of the feature has been required. But I hope you understand why exactly we need an inheritance over here is, with some or the other case, if you're not implementing the base thing, at least the parent class's method would be getting executed. So it's something like you're having your own back. So maybe in the further flow, and let's assume that it's not a print statement. Maybe it's a sum of the class. Maybe it's some variable. That variable would be updating over here in the respective convert. Maybe you can write the number, the size of the convert is maybe in JSON it is only 1 MB, maybe in XML it's a 2 MB, something like that. So maybe in the further of the flow you can check it out what exactly here I'm printing. That's a different case. But what if you're returning some value? You can catch it. Maybe you can put on some flags and switches, skill switches, something like that. It'll do the work for you.
Thank you.
So all we are trying to do is not to encounter any sort of an error in a real-time situation, in a real prod. So if you're not putting, the chances are high that if somebody forgets to write the default methods, maybe there's a new guy in the team or there's a new person in the team and he forgets to write default methods which have been using in the current flows, this sort of a thing, it will break an application. You really don't want to see an error on any of your application, correct? The users will be getting irritated the moment they see any error. So to save ourselves from getting this error, So we do the best what we can. Any questions, guys? Okay, I think no, thank you. Perfect. Anyone else? We still have more 15 to 20 minutes. Mm. Shall I? What do you want me to guys talk about in next 10 to 15 minutes, I guess? Okay. Okay. I have to log off for a call. Thank you.
Thanks, guys. Thanks for attending. If no further question, we can close the meeting.
Oh, okay. I thought maybe we can.
Okay, fine.
How about some one or two DSalgo questions? If anyone is interested.
Or maybe we can schedule it the next meeting.
Okay, perfect. I have no issues. Okay, thank you all. Thank you so much. If you have no more questions, maybe we can drop the meeting.
Thank you so much. This was very clear. Thank you. I really appreciate it.
Thank you so much, Saida.
Thanks. Thanks, Anupama.
Thank you so much. Thank you, guys. Thank you for the opportunity. Yeah.